Hello friends, welcome to follow up. Let's have a look at problem 2140, solving questions with brainpower. In this video, we're going to explain a solution based on dynamic programming. In this question, we are given a zero-indexed 2D integer array called questions, and each element in the questions is a list which contains two elements. One is point and the other is brainpower. So the array describes the questions of an exam, where we have to process the questions in order. In other words, starting from question 0. And also we need to make a decision whether to solve or skip each question. So here is the rule. Solving question I will earn us this number of points, but we will be unable to solve each of the next brainpower questions. So if we skip question I, we get to make the decision on the next question. So here is an example. So first, if we solve question 0, so we earn 3 points, but we can, because here the brainpower is 2, we cannot solve the next two questions. In other words, a question at index 1 and a question at index 2, right? Then we can solve the next one, depends on if we want to solve it. So in this case, if we solve the first one, and then we can start solving the last one. So this will give us a point 3 plus 2, right? This is actually also example 1. Here we want to find the maximum point we can earn for the example. So for example 1, so the output is 5. Here is as the explanation, right? In example 2, the point is 7. So we can solve a question at index 1 and a question at index this is 4, right? So before we move forward, let's also look at the constraints. First, the length of this list questions is bounded above by 10 to the power 5 and bounded below by 1. So the lower bound tells us this list is not empty, and the upper bound basically constrains the problem size. And the question, each element in the question is a list of length 2, and the points and the brainpower is bounded in between 1 and 10 to the power 5. So this is the main statement of this question. So actually for this question, so the hints are very suggestive. So if you do not have an idea on how to solving it, you can first look at the hints. So here we are not going to go into the details. So now let's explain the overall idea. So here, if you just look at the question, it might be difficult to think of way. But if you analyze using DP, actually the problem becomes natural or easier. So here, let me write down. The method we're going to use is dynamic programming. So here, basically, I'm going to use tabulation. This is just for the ease of explanation. So I'm going to define a DP table having the same length as the questions list. So here, I'm going to interpret DPI as the maximum point one can earn if we're starting the exam from index I, right? So in other words, we consider the tail. And then if we can assume that the length of this list is m, right? So if we are at the last index, that is m minus 1. So to earn the maximum point, we can only choose to solve that question. So we are going to have this points, right? This number of points. So this is the one initialization we can regard it as, or the set of the last index. And then what we are going to do is to set the DP table for index I from large to small. So here we can have the recursion rule. So it's DPI. So at index I, so we can choose to solve that question or choose to skip that question. If we choose to escape that question, then the maximum point we can earn starting from index I will equal to the maximum point we can earn starting from index I plus 1. So this is the first factor or first argument in the max function here. And another option is that we choose to solve the current question at index I. So this is the point or score we can earn by solving this current problem at index I. But by assumption, we needed to skip next several questions. In other words, we need to skip this number of questions. In other words, the brain power at index I. That is questions I at index 1. So because we need to skip this one, so here we need to write I plus this skip and then plus 1, right? So this is important. So this is a general DP update rule. Actually, we need to consider the situation that this index can be out of bounds, right? If it's out of bounds, there will be no question to solve. We can only get this part, right? So this is the general idea. So, and after we set the DP table, what we need to do is to return the max elements in DP. In other words, the maximum points we can get is the maximum point by examining starting from each of the index. So that's the overall thought. So with that said, we are ready to write the code. So as for writing the code, so there are some details we need to fix. Let's walk through this and explain. So first, I'm going to get the length of questions. So this is just for convenience. So here, in this in here, if we can specify DP is length n array, then we set DP n-1 to be this number. However, another way to treat it is to initialize a DP table of length n plus 1. Then we can regarding that starting from index n will have a point 0. So that way it just save some writing might be or just another representation format. So this is the tiny details. So next, let's first set this part. So we set for n-1, right? And next, we're going to set other parts by iteration. So it's basically a for loop. So we're going to start from index n-2, right? Because we have set n-1, and then -1 and -1. So here, this is stop index, but the range function will stop before this one, and the increment will be -1. In other words, each time we decrement the index by 1. So this way, let's first get the current score and the skip, right? So this will be questions I, right? And then we're going to set this DPI. So we can copy this part, DPI. Let's write use first if I plus skip plus 1 is less than n, right? In other words, it's inbound. So let's do this. So DPI will be max of this plus this will be the score, right? Score plus I plus the skip plus 1. So this is the inbound case. Otherwise, so let's copy this part again. So this is the maximum. Then we just can have score because this is the outer bound. So there's no question left for us to solve. So we have this one. And then what we are going to do is to return the max DP. So this forms a solution format for this question. Let me first do a test. Yeah, it passes one example. Now let's look at the generic case. yeah, it passes all the generic cases. So here, after we solving this, after we test this, so let me make some small adjustment. So here, let's call this one v1. We can run a running variable so that each time we set this one, so we can just take maximum. For example, let's see, we can set result equals dp n minus 1, right? And then each time we set this part dpi, so we're going to see result equals max result, the previous state, and the current dpi. And this way, we just need to return the result variable at the end. So now let's also test this. Yeah, it actually gives the correct result. So another thing is that let's copy this part again. So I'm going to call this format v2. So now here, after we get this one, so we can use a one with index n plus 1, and then we just set then we can here, then dpn will be 0 automatically, so we can see result equals 0 set at the very beginning. And then what we are going to do is we are going to do this, right? And then we get skip, and then we do this, right? Well, here let's I changed it here. Now let's see. Let's use this v2. Let's not do this. n minus 1 equals dp questions n minus 1 0, and the result equals dp n minus 1, and then we start from n minus 2. So now let's modify this one. So we can do this one plus 1, and then we don't need to specify dpn here. So we can start the result to be 0, and then we can start from n minus 1, right, in this case. And then it's the same thing, right? Let's test the case. Yeah, so basically this are just some small tweaks or details, but sometimes when you solve a question, this kind of tweaks can be important. So with that said, basically that's about it for this specific question. So you're welcome to follow up for other problem analysis, or just share with your friends if you find this explanation of use. Thank you.